if we have an example like this, where we have, this is a trig equation, we have an equal sign, we have trig functions, and there's trig functions on both sides, so what we need to do, they're both sine functions, so let's gather all like terms. And again, in solving these, we have to get the trig function all by itself on one side. We're not isolating the variable, we're not isolating this, we're getting a trig function all by itself on one side of the equation. Okay? So let's subtract. It's a smaller one over here, so let's subtract from both sides. 5 sine theta minus 3 sine thetas would be 2 sine theta. And let's get rid of this 2 as well. Equals negative 1 over here. Okay, does everyone see how that first line turns into the second one there? All right. So again, I'm not stopping here yet because I want to get my trig function all by itself. So I'm going to divide by 2, both sides. So the answer to this equation lies where we're looking for the angle to which the sine of that angle equals negative 1/2. Okay, so that's what it kind of all boils down to. Now again, we cannot go any further. It's not like you're dividing by sine here, or sine just by itself, right? We can't do that. This doesn't make sense, so we can't isolate. But now we look at our unit circle, and if we look at that unit circle, let's just bring that down here so we can take a peek at a little bit at a time. So where does, what angle provides a sine of negative 1/2? So we know sine's the second one, so, oh, there's positive 1/2. Nope, 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 nope. Keep working yourself around. These are positives, and down here you'll find that we have negatives, right? And so what's the first one we run into? Is it between 0 and 2 pi is 7 pi over 6. The other one would be 11 pi over 6. So theta is then going to be equal to 7 pi over 6 and 11 pi over 6. Okay? And that's under the specified domain between 0 and 2 pi. Got it? Put what? The domain? No, the domain will be given in the question. Like. Okay, yeah. No, if you're looking for theta, you can write it like this. Yeah. You can also write solution set equals with the braces. Yeah. So you could do this. Yeah, but ideally, if you have whatever variable is in the problem, you should have that in your answer as well. So I wouldn't do the solution set, that way. I default to this. So you are finding theta as the question. So yeah, this would be preferable over just. Yeah. Okay. So if we had to figure this out on our calculator and it was approximate answers that we were looking for, then you would simply go like this. You would take the inverse, really, of both sides. This is how you actually get rid of sine. And you guys have seen this before. Sorry, to the negative 1. So the inverse of sine of the negative 1, actually does get rid of sine. You can't divide it off, but that's how you do it. You take the inverse of sine and you multiply it. Remember, inverse, a number and its inverse always equals 1, right? So if you multiply inverse of sine times sine, that is 1 times theta. So that's how you actually get theta using your calculator, and you put that in. So this one obviously, well, let's just see. So if we did this, you do second function sine of negative 1/2, or 0.5. And your calculator is going to give you this for a value. Okay, it's only going to give you 1, and so you don't know if there's any others. This is just the smallest angle that will give you this trig function of negative 0.5. And so negative 0.52, now you would write this as a decimal. You'd have to truncate it somewhere, so it's going to be approximate. But which answer here, now again, which answer would this refer to? Which answer would this refer to? Well, negative 0.52598, what is that in radians? Can we figure that out? So let me clarify here. If you are doing this like I did this, see my calculator's in radians. So your scientific calculator may be in degrees. And obviously you can switch the mode of your calculator if you want, and then it'll give you degrees. So and that's one way. You could, you know what I mean? If you want to go radians to degrees, you just flip your calculator to degrees, and it should give you, is it 30? Negative 30? To get negative 30? Okay, so putting that conversion for your calculators aside, let's say this is negative 30 degrees, which it is. Why is this answer that we get not the same as these? Because what's negative 30 in radians then? That's going to be what? Negative pi over 6, is it not? So negative pi over 6. So this is actually negative pi over 6 in exact form. So what's the relationship between these numbers and negative pi over 6? Well, I'll just erase some of this stuff here. The relationship, anybody noticing what it is? What's the relationship between negative pi over 6 and these numbers? Let me draw this unit circle for you. Anybody? So 7 pi over 6 is about over where? Here? And 11 pi over 6 is about over here, right? Or so. So what is negative pi over 6? Where's negative pi over 6? It's right here. That's negative pi over 6, right? So pi over 6 in the negative direction gives you one of these angles. It will be the same as that one. But pi over 6, more importantly, is the reference angle. Okay? Do you remember what a reference angle is? Reference angle. So here's my point. The unit circle, very helpful. Very easy for us to get these values as opposed to using the calculator. Calculator is going to give us probably a decimal. You're going to have to convert that into exact value in terms of pi. Then you're going to have to determine, hey, that's actually a reference angle, because that's what calculators do. They spit out reference angles. They don't spit out exact angles all the time, because they don't know which exact angle you're talking about, right? There's an infinite number of them. They don't know what the specified domain is. So you have to figure out the reference angle, then you have to do some subtraction, some adding to get the actual angles. Plus you have to use the cast rule in your head. So unit circle is very handy, going to get you to answers very quickly. Does that make sense? So you still can do it. You say, okay, negative pi over 6 gives me one angle. Is there another quadrant that gives us a negative sign value? Well, this sign's positive here, sign's positive here, it's negative here, and it's negative here. So you have to figure out what this angle is. So that would be pi plus pi over 6 to give you 7 pi over 6. This one here, right here, is 2 pi minus pi over 6 to give you this one here. So unit circle is our friend. Yay. Negative 1/2. Boom. Done. Negative 1/2. Boom. Done. Answers. Got it? Okay. I won't deal with the general solution here yet, but that's how you do that question, and that's why unit circle is going to help us out quite a bit here. Questions?